today our topic is use the chain rule to differentiate more complicated functions, right? So here we study a new rule, that is chain rule. That is very famous and very easy rule to differentiate different functions which are complicated. Consider the functions y is equals to 1 plus x raised to the power 10. This is a complicated function. We have to find the derivative of that function. Okay. One way of calculating dy by dx is to use the binomial expansion. By using binomial expansion, first of all, we have to expand this formula. We have to expand this fraction. Then we have the terms like x raised to the power 10 plus something raised to the power 9 plus something raised to the power 8 up to so on, a constant number. But that way is very difficult to solve, because first of all we have to use binomial expansion. That will be very time taking process, but this is a very long and inefficient way of calculating it. Okay. Another way is to use the chain rule. So we have to use the chain rule to solve these type of questions. So what is chain rule? Chain rule is written in this way that if we have to find the value of dy of dx, dy over dx, that will be equals to dy by du multiply by du by dx. So by mathematically, if you can see this right side, du can be cancelled out by du. Now you can see that your left hand side and your right hand side are same, but we have not uh, allowed to cancel these terms because we have to use these terms in the question. So first of all, we have given a complicated function that y is equals to 3x square plus x raised to the power whole 5. This is the example 5, right? So first of all, you can simply suppose that the inner function, that is 3x raised to the power 4 plus x, this is your inner function. Let this function be u, right? So this is the u which we use in this formula. Okay. Now we can see that we have to find dy by du for the formula and also du by dx for the formula to put these values into this formula. So first of all, this is u and this expression is in terms of x. So we can find the derivative of y, the rate of change of u with respect to x. So we can write it as du by dx. So du by dx can be found because in previous terms you have some terms like y is equals to x square plus 3. So we can find in this expression that rate of change of y with respect to x. But in that case, our expression is in two variables which are u and x. So your derivative will also change as rate of change of u with respect to x, or you can say that du by dx. So how we can find the derivative? By previous method, by power rule, the power goes on start and multiply by this constant. It will becomes 12 and the power is 1 less than its parent power. So it means that 12x raised to the power 3, and here is the x, and you can see that x has the power 1 So its derivative will becomes 1 goes on start x raised to the power 1 minus 1. So x raised to the power 1 minus 1, that is x raised to the power 0. So any number, any variable, any constant which has the power 0 will be equals to 1. So it means that we write it 1. Do you understand this or not?
Yes.
Okay. Now we have found the value of du by dx. Now we have to find the value of dy by du. So for finding the value of dy by du, we just put the value of u into your question. So you can see that your equation will becomes y is equals to u raised to the power 5. Understand this term? Now in this case also, in previous you can see that y is equals to x square plus 3 is given, then we can find the derivative of y with respect to x, because here we use two variables, y on the left side and x on the right side. Again, if we have the expression y is equals to u raised to the power 5, it means that now we use two variables which are y on the left side and u on the right side. So we can find the derivative of y with respect to u. So how we can find the derivative of y with respect to u? By using the power rule. And what is power rule? Dy by du is equals to, this 5 goes on start, it will becomes 5 u raised to the power 4. This is your equation 2. This is your equation 1. Do you understand till equation 2?
Yes.
Okay. After that, you can see we use the formula of the chain rule, that is dy by dx is equals to dy by du multiply by du by dx. So it can, this formula can be changed if you use other variable here in the space, in the place of u. If you are supposing that this fraction or this expression is not u, it is something other than u, so we uh, change our formula, that dy by some variable and also some variable over dx, right? So this formula can be changed. This is not the perfect formula, so we can change according to our supposition, right? So here we have dy by du multiply by du by dx. So what is the value of dy by du? That is 5 u raised to the power 4. We just put this value into this expression, and also du by dx, which is given in equation 1, we have to put this value into this given equation. So your answer will be 5 u raised to the power 4 multiply by 12x cube plus 1. This is your answer. But you can see that our fraction, our starting question is in two variables which are y and x. It means that its derivative will also be in x. So here one other variable is given, that is u on the right side. So we have supposed the value of u, we just put the value of u in the last expression, which can be written as 5 times 3x raised to the power 4 plus x raised to the power 4, which is the value of u, multiply by 12x cube plus 1. So this is the derivative of this complex function. Do you understand this process or not? This is called the chain rule.
Yes. Okay, but I have a question. To use the chain rule, does there have to be like a whole power or the whole? Um.
Sorry, what are you saying?